Hello guys, in this video we'll be discussing about the derivation of a unit step response of a second order system for underdamped case. Underdamped, basically zeta value will be less than 1. For that case we are going to discuss the derivation. Okay, second order system. Now as we talk about second order system, we have to understand the CLTF. What is CLTF? Closed loop transfer function of a standard second order system is given as C of s by R of s, which is equal to omega n square by s square plus 2 zeta omega ns plus omega n square. Now omega n is nothing but the natural frequency of oscillations. Okay, now this thing you have to remember. Okay, so let us go for the derivation part. Derivation part, you have to take the first step is that you have to take the characteristic equation. And now what is characteristic equation? So characteristic equation basically means the denominator part of the closed loop transfer function, that is this one. So s square plus 2 zeta omega ns plus omega n square equated to 0 equation, right? So characteristic equation we have taken. Now for this we have to find out the roots. So how many roots will be there? There will be 2 roots. Now in order to, since it is quadratic, right, so there will be 2 roots. In order to find the roots of this, you can go for the formula minus b plus or minus root b square minus 4ac by 2a. Simple thing. This is the standard formula for quadratic. This is quadratic, right? So for that we have to apply this formula. So standard form for that is ax square plus bx plus c equal to 0. Now when you compare what is a, what is b, so let me write what is a. A will be equal to, here x square, here it is s square. Okay, so a will be 1. Now what will be b? B, you can observe, this is s is there, rest will be b, 2 zeta omega n. Then what is c over here? C, observe carefully, it is omega n square, whole thing, not omega n, it is omega n square. Okay, so when I apply this formula, let me apply this formula, minus b. So minus b value is 2 zeta omega n plus or minus under root of b square, that is square of this, 2 square is 4, zeta square, this is zeta, okay, omega n square, correct, minus 4ac, minus 4 into, what is a is 1, what is c will be there, so minus 4 ac. Okay, whole thing divided by 2 into a, what is a, 1, so this will be the final thing. Now from this I can just simplify this equation. So what I can do, I can take 2 outside, so this will be minus 2 will be there, omega zeta omega n plus or minus, from this can I take 4 both common? Okay, I'll just write it. So 4 is common for both, as well as omega n square is common. So what is remaining? Zeta square minus 1, whole thing divided by 2. So for this thing I can take it outside. Square root of 4 is what? 2, right? So I can take it outside. It will be 2 zeta omega n plus or minus 2 will be outside, and omega n square, square root will be omega n, it will be outside, under root of zeta square minus 1 divided by 2. Now next step, I can take 2 common and cancel with this. So 2, taking 2 outside, so what happens? So z minus n will be there, zeta omega n plus or minus omega n into zeta square, square root of zeta square minus 1. This whole thing I need to divide it by what? 2. Get cancelled, right? So what is the remaining thing? This will be the final. So I can write it as minus zeta omega n plus or minus omega n into square root of zeta square minus 1. So for this, what I'll do, I'll interchange the sign. I'll bring 1 minus zeta square. So what will happen? I have to include 1. So I'll carefully observe zeta omega n plus or minus j. I'll include j here. Omega n into 1 minus zeta square. So this will be the roots. Okay, this will be two roots are there. One is plus, another one is minus thing. Okay, so 1 as well as second. So both roots are present here. So this is the step in order to find out the roots. So we have found out the roots. Now the next step is that we have to assume. Okay, let us assume that this zeta omega n in this to be alpha. Okay, let us assume that. Then one more thing, the omega n into square root of 1 minus zeta square, this part, imaginary part, to be what? Omega d. As we know, it is equal to what? Omega d itself. Okay, omega d, what is omega d? Omega d is nothing but the damped frequency of oscillation. This is natural frequencies, this is damped. Okay, there is a difference. Both are frequency only, but natural, and this is damped. So what will happen to the roots? Now it will become 1 comma 2 means both the roots are included, minus alpha plus or minus j omega d. So this will be the final roots. Okay, as I have assumed these things. Now the next step is that since this is unit step response, so I have to consider the unit step. So what will happen here? Carefully see, close the system. I'll consider again closed loop transfer function, which is equal to omega n square by s square plus 2 zeta omega ns plus omega n square. Here what I'll do, I'll consider r of s as 1 by s. Why? Because unit step. Okay, so reference input I'll consider as what? Unit step input. R of s is equal to 1 by s. Now, so when I multiply R of s that side, what will happen? C of s is equal to R of s into omega n square by s square plus 2 zeta omega ns plus omega n square. That is equal to R of s is 1 by s. So 1 by s I can bring it down. So anyways, 1 multiplication is the same thing. Omega n square by s into s square plus 2 zeta omega ns plus omega n square. So this is the thing. Okay, 1 by s is automatically it comes to the denominator s part. Okay, so 1 no need to consider. Anyways, when you multiply with omega n square, it will be the same thing. Now the next step is that you have to go for partial fraction method. Now in partial fraction, as you have studied, we have linear factors. This one is quadratic. Okay, this one is linear, this one is quadratic. So how I can form that? So C of s, which will be equal to, carefully you have to see, omega n square by s into this part is there. So I'll consider it as a by s plus b, s is the variable, s plus c divided by s square plus 2 zeta omega ns plus omega n square. So basically I am splitting up using the partial fraction method. In partial fraction method, linear factor is there, you have to consider only one variable. Whenever you get quadratic, you have to consider in this form, b s plus c. S is the variable, that's why s comes here. Okay, now the thing is that I have to find out a value, b value and c value and put it here, and I have to find out. See, basically our intention is to find out c of t. How can I find out c of t? Basically we have c of s. Now in order to bring it to c of t, I have to perform the inverse Laplace transform. Okay, this is an S domain, Laplace domain. So in order to bring it to the c of t form, I have to perform inverse Laplace transform. So that's why I'm keeping a c of s on the left hand side. Okay, the c of s is nothing but this only. Okay, c of s is nothing but this. So c of s I can write it as omega n square by s into s square plus 2 zeta omega ns plus omega n square, and which is equal to C of s. I wrote this part, and this part how will I simplify? Just cross multiply, take the LCM. When you take the LCM, you have to just cross multiply. That means this into this, this into this, and this into this. Okay, cross multiply, LCM, taking LCM. So this will be a into s square plus 2 zeta omega ns plus omega n square, okay, plus bs plus c into s is there, into s, divided by s into s square plus 2 zeta omega ns plus omega n square. Now simple thing, this two get cancelled. Okay, what is the remaining? Omega n square is equal to a into, I'll just simplify this, open the bracket, a into s square plus a into, that I'll write 2a into zeta omega n s plus a omega n square plus bs square plus cs. Carefully you see, this is actually multiplication of this two. Okay, s into bs, it is bs square, c into s is cs. Now this we got. Now from this we have to find out a, b, c values. Before that, one more thing I can do, I have to combine the like terms. Here you can see s square is there, s square is there, then s is there, s is there. I'll combine that terms. Now how will I combine? See here carefully. So s square I'll take. So what will be inside? A will be there plus this thing is there, b plus b plus s I'll take outside. So what will be there? 2a zeta omega n, sorry, plus one more term is there, where is s? This term, so it is c. Okay, plus what is the remaining term? A into omega n square. So this is the term we got. Now what I can do, I can equate the constants, then coefficient of s square, coefficient of s, that all things we can do. Constant here, it is omega n square. Remember this thing as we discussed, this is the c, right? So this is a constant part. So equating, I'll do equating constant. So when I equate constants on LHS as well as RHS, on LHS part I have omega n square equal to RHS part I have a into omega n square, correct? Next, equating the coefficient of s square. S square coefficient I'll equate. Now in the LHS part I don't have any coefficient of s square, so it is basically 0. So 0 is equal to, on RHS part I have a plus b. Don't write s square, okay? Coefficient of I am equating. Next thing, equating coefficient of s. Okay, coefficient of s. In LHS part I don't have any s term, so it is equal to 0. RHS term I have coefficient 2a zeta omega n plus c. So from this, first what I'll get? See, omega n square get cancelled. So what is remaining? A equal to 1, right? This a equal to 1 I got was first value. This a I'll put it over here in this equation. 0 is equal to a plus b. So what will be b value? B value will become minus 1. So a and b value I got, correct? Simple thing. Put it here, 1 plus b equal to 0. So b value will be minus 1. Next, a b value I got. So a value I can put it over here and get the value of what? C, correct? So 0 is equal to a value is what? Nothing but 1. So c becomes what? C is equal to, so I'll write it, c is equal to minus 2a zeta omega n. Now in this zeta value, a value I'll put, which is equal to what? A value is minus 2, a is 1, correct? A is 1, so zeta omega n. So this will be what? C value. Minus 2 zeta omega n will be c value. So all the values I got. Now what I have to do? I have to put it in back to the this equation, c of s equation. So what happens? C of s will become what? See here, a by s. What is a value? 1. So it will become 1 by s plus here bs plus c. What is b value? It is minus 1. So it will be minus s plus c value is minus 2 zeta omega n divided by, okay, c value is minus 2 zeta omega n divided by this whole thing. So s square plus 2 zeta omega ns plus omega n square. Now as we discussed earlier, we have assumed zeta omega n as alpha. So I'll be substituting in this. So 1 by s plus minus s, this is minus 2 zeta omega n will be alpha divided by s square plus 2 zeta omega n is there, again alpha into s plus omega zeta omega n only, okay, omega n square. So this will be the final C of s. Now rest we have to do more steps you have to do. Now the thing is that if I take minus outside, what will happen? 1 by s minus I will take outside. So what will happen here? S plus 2 alpha by s square plus 2 alpha s plus omega n square. Okay, so this will be the final thing. Minus I have taken outside, so this will become s plus 2 alpha. That's it. Now the thing is that denominator you can see s square plus 2 alpha s plus omega n square is there. For this denominator we have to go for the method completing the square. So we need to simplify what this thing, this denominator. So taking the denominator, what happens? S square plus 2 alpha s plus omega n square. This thing I need to simplify. For simplification purpose, we have to go for completing the square. Completing the square. As we know the completing the square method. So one small example I will give you, okay, just for the reference purpose. X square minus 6x minus 2 is that quadratic form. Okay, so here I have to do the completing the square method. What I need to do, whatever the middle term is there, that term you have to take and divide by 2. So you'll get it as what? 3. Don't think about the sign, only take the coefficient without the sign. That means it will be positive. So 6 by 2, I'll get 3. This 3 you need to square and add it to this whole term. So it becomes x square minus 6x plus 3 square minus 2. Then I need to subtract that thing, 3 square. Simple. I'll repeat again. Middle term you have to divide by 2 and take the square of that answer and add it to this term. See, x square minus 6x, then I will add 3 square, then minus 2 is already there. When you add 3 square, you need to subtract 3 square also, right? Because this term, see, as you can see, this term, if I'll subtract this term, then it will not disturb this equation. It will remain as it is. These two get cancelled. But the thing is that, but I'll combine these two. Okay, this thing you can leave. This is for just reference. As you can see here, s square plus 2 alpha s plus omega n square. Compare with this, middle term is 2 alpha. Okay, s is the variable here. So middle term I'll take and divide it by what? 2. So this 2 get cancelled. What is answer? Alpha. I have to square this alpha. So it will become alpha square. So I need to add with this term. So s square plus 2 alpha s plus alpha square plus this omega n square is there. Then I need to subtract whatever I have added. Here I have added alpha square, so I need to subtract that alpha square. Now when I combine this term, these 3 terms, as you can observe, this is nothing but s plus alpha the whole square. Carefully see, this is nothing but s square plus 2 alpha s plus alpha square. What is remaining? Omega n square minus alpha square. Simple. Now what is alpha? Alpha we have assumed it is what? Omega zeta omega n, correct? So carefully see, I'll simplify this equation. S plus alpha the whole square plus omega n square minus alpha square, so it will be zeta square into omega n square. Okay, so when you see this, I can take out omega n from this, not omega n square I can take common. So what will be remaining? 1 minus zeta square. Correct. Now the next step is that, as we know, omega d is equal to what? Omega n into under root of 1 minus zeta square. So if I want to find out omega d square, it is nothing but omega n square into 1 minus zeta square. Correct? The square root will get cancelled. Simple thing. So it's the same thing. You can see over here RHS part, RHS part. It is nothing but omega d square. So I can write this as s plus alpha square, alpha the whole square, into this is nothing but omega d square. Okay, remember this, it is omega d square, not omega d, it is omega d square. You can just refer this one. Now this is the simplified version of a denominator. Now I'll take this and put it over here. So what will happen, our c of s will become 1 by s as it is minus of s plus 2 alpha divided by this denominator will be this one you have to put s plus alpha the whole square plus omega d square. So this is the simplified version of, we are simplifying c of s such that we have to take inverse Laplace transform, okay, in order to get c of t. That's why we are simplifying these equations. Now we'll directly go for Laplace inverse. Okay, now for going for Laplace inverse Laplace inverse, okay, for that we have to remember a few formulas. That is inverse of s plus a by s plus a the whole square plus omega square, which is nothing but e power minus at into cos omega t. One more formula, Laplace inverse of omega by s plus a the whole square plus omega square equal to e power minus at sine omega t. These two things you have to remember. What is the difference between these two? It is s plus a is there in the numerator, here it is omega, so it changes. Here it is cos omega t e power minus at cos omega t, here it is sine omega t. That's the difference. So these two formulas you have to apply here. For that purpose, if you carefully see this part, okay, 1 by s it is directly 1 itself. Laplace inverse of 1 by s is nothing but 1. Okay, so I'll just simplify this. So what happens, 1 by s as it is minus, carefully you see s plus 2 alpha is there. So what I'll do, I'll take 1 alpha here, that means s plus alpha, 2 alphas are there, right, divided by s plus alpha the whole square plus omega d square plus one more alpha here. I'm just adjusting this equation, that's it, s plus alpha the whole square plus omega d the whole square. Okay, omega d square, it's the same equation I am splitting up. That means s plus 2 alpha is there, 2 alpha I am splitting to alpha plus alpha, that's it. Now after splitting, if you see this equation, it directly matches with this s plus a by this thing. Carefully observe this two. Okay, for this thing I need, here omega is there, here omega square, I need the same variable. Here it is omega d square, so I need here what, omega d. So in order to bring omega d, what I have to do, see here, I'll multiply omega d and divide by omega d, that's it. Divide, where I'll divide somewhere here. Okay, multiply and divide by omega d for this particular equation, only for this particular equation. Okay, so such that I can bring it in this form. So okay, what will happen, so I'll rewrite again, c of s is equal to 1 by s minus s plus alpha by s plus alpha the whole square plus omega d square plus this alpha and omega d is extra, correct, into omega d by s plus alpha the whole square plus omega d square. See, basically what I have done, omega d I multiplied and divided, alpha is one extra term, so I'll bring it over here. Now it's the same thing, see, omega is there, omega square, omega d square is, omega d is there, omega d square is there. Compare this equation with this and this equation with this. Okay, so now I can directly go forward Laplace inverse. So taking Laplace inverse, what happens? C of s will become C of t, small c and small t, which is equal to, as I said, Laplace inverse of 1 by s is 1 minus, this is nothing but e power, see here, e power at cos omega t. So e power minus at, in place of a I have alpha. So alpha t cos omega, it is omega over here, but here it is omega t. So omega dt. Understand the, like, compare and understand the difference what happens here. Now next thing, here alpha omega d, so I'll write plus alpha by omega d, and here, so, and one more thing, this minus sign is there, so I'll take minus sign inside. So minus I have taken here, minus also I'll take here, this becomes minus. Okay, bracket is there. Now this thing I can write it as e power minus alpha t, this one sine omega d, that will become sine omega dt. Okay, so this will be the final thing. Now here again the same logics you have to apply. So what I can do, omega alpha is equal to what, zeta omega n, correct? And one more thing, we assume omega d is nothing but omega n into 1 minus zeta square. These two things you have to apply here. That means wherever you find alpha, you have to replace with zeta omega n, and wherever you find out omega d, I have to replace with omega n into under root of 1 minus zeta square. So what will happen? C of t, so let us see here, C of t will become 1 minus e power minus alpha is there, so zeta omega n t, then cos omega dt, correct? So this will become what? Omega dt. Thing is that don't change, this is an angle, okay? So we cannot substitute directly here omega d in place of that omega n into 1 minus zeta square, no. Okay, so whatever cos is omega dt is there, it will remain as it is, and here sine omega dt is there, it will remain as it is. But the thing is that here one omega d is there, for that you have to replace alpha, it is zeta omega n divided by omega d is there, which is omega n into 1 minus zeta square, into e power minus alpha is there, zeta omega n t into sine omega dt. So this two get cancelled, omega and omega n. I can take e power minus zeta omega n t common. Yes, so what will happen? 1 minus e power minus zeta omega n t common. So inside what will be remaining? Cos omega dt minus, I'll take minus outside, it will be plus, correct? If I take minus outside in the bracket, it will be plus. Okay, so e power minus zeta omega t common, so what is remaining here? Zeta by 1 minus zeta square into sine omega dt. Okay, now what I'll do here simplification, I'll take LCM here. So when I take LCM here, what happens? 1 minus e power minus zeta omega n t, taking LCM, that means 1 minus zeta square I have to multiply with this, correct? So 1 minus zeta square into cos omega dt plus zeta sine omega dt, whole thing divided by 1 minus zeta square. Okay, so I have taken just LCM. When you take LCM, this you have to multiply here, and plus this remains as it is, and this one. So this thing I can take it outside. Now it will become 1 minus e power minus zeta omega n t, okay, divided by this, I'll take outside, 1 minus zeta square into 1 minus zeta square cos omega dt plus zeta into sine omega dt. So this will be the final C of t. Okay, so this will be the final C of t. Now here when you see, comparing with sine omega dt plus theta, sine a plus b, sine a plus b is what will happen, sine a, that means sine omega dt into cos b plus cos a into sine b, correct, sine a plus b. Now here as you observe, see these two equations. When you see these two equations, you can observe that omega cos omega dt cos omega dt, sin omega dt sin omega dt. Now then what will be cos theta and sin theta? See these two and these two gone. So what is remaining? Cos theta and sin theta. Then sin theta will be what? This one, right? See cos omega dt. So sin theta will be, I'll write it, sin theta will be 1 minus zeta square, and cos theta will be, what is remaining here? Zeta. So from this can I write tan theta? Tan theta is nothing but sin theta by cos theta, so which is equal to 1 minus zeta square by zeta, correct? This is the important thing. So from this I can write theta value. Theta is nothing but tan inverse of, so theta will be what? Tan inverse of 1 minus zeta square by zeta. This is important. This theta will be in radians, not in degree, radians. Okay, now what will happen now? So this whole thing, whatever is there, can I replace it as, see here, c of t is equal to 1 minus e power minus zeta omega nt by 1 minus zeta square into this whole thing. What I'll write it? I'll write it as sine omega dt plus theta. This is the required expression. This is the final c of t. So as you can see, what I have done, this whole thing is nothing but, it is same as this sine omega dt plus theta, which is nothing but sine omega dt is there, cos theta is there, then cos omega dt, then sine theta is there. So I will replace this with this. Okay, now here you can observe what is theta. Theta is nothing but this formula. What is omega d? Omega d, as we discussed, it is nothing but omega n into 1 minus zeta square. This formulas you have to remember. Okay, while solving problems and all, we'll solve problems based on this in next video. So this is the final required transient response of what? Second order system, unit step response of the second order system.